By 7.9 billion years from now, Mercury, Venus, and most likely Earth will be totally swallowed by the Sun and cease to exist. During these times, however, it is hypothesized that a moon of Saturn named Titan could achieve surface temperatures warm enough to support life.
Saturn will be in the habitable zone, and its cold moon Titan, that currently averages a temperature of minus 179 Celsius, will finally have a good temperature for human life and life in general.
Hi guys, recently I found that many people were buying into a common myth, and the myth is that Titan along with its parent planet Saturn will be at the habitable zone when the sun becomes a red giant. And it's universally accepted that the sun will become a red giant when it runs out its fuel of hydrogen and begins to fuse heavier elements. And it will probably expand beyond the Earth's current orbit and will be 256 times bigger than the current sun in terms of diameter when it reaches its peak in its red giant phase. However, one thing that we still debate on a lot is where exactly would the habitable zone of the red giant sun be at. Most people agree that it will be at the orbit of Saturn, but some people say that it will be smaller at the orbit of Jupiter, and some even claim that it will be at the orbit of Mars, simply because Mars's new distance to a red giant sun will be quite similar to Earth's distance to a current sun's surface. However, this doesn't look realistic at all because of the sun's massively increased size and energy output. So many people say that it will be at the order of Neptune, and some even say that it will be beyond that. And the only way to find out where exactly would the sun's habitable zone fall at is to use mathematics. Let's imagine that all stars, including the sun, are surrounded by a sphere, and the formula for a sphere is 4 times pi times r squared, and r is the radius of the sphere. The formula I just mentioned is the formula for the area of the sphere. And when the radius of the sphere is double, then the area is quadrupled because the area is directly proportional to a square of the radius of the sphere. And because the radius of the sphere is doubled, then the area of the sphere is multiplied by 2 squared, which is 4. And the planet that orbits 2 times farther from the star than another planet would receive 4 times less sunlight than the planet that is closer to a star, because while the areas of the planet and the radiation output of the star remains constant, the area that the star's radiation output is far larger than the sphere for the planet with a smaller orbit. And because the star's radiation output remains constant, but the radiation has to cover a much larger area for a planet with a larger orbit, then the planet with a larger orbit will receive 4 times less radiation from the star because it covers a area that is 4 times less than the proportion that is covered by the planet with a smaller orbit. And therefore, we could establish a formula to calculate the planet's radiation receiving from its parent star. L, which is the luminosity of the star divided by the distance between the planet of the star squared. And now we can calculate the habitable zone of the red giant sun. And by the way, I'm saying that the red giant sun's peak luminosity in this video. Of course, the sun will be less luminous for some time before it reaches its red giant peak. So its habitable zone will scrape past some planets before it finally reaches those objects that will be habitable when the sun becomes its peak in its red giant phase. And this is a 2-scale representation of the solar system today. When the sun becomes a red giant, it will become that big and have a luminosity of 3,000 times greater, which is a lot less than the 65,000 fold increase in the sun's luminosity if the sun remains the same temperature. Because when the sun's temperature decreases, it means that the photon energy and therefore the energy output of the sun decreases, and therefore the sun will be less luminous than it otherwise will be if a sun has the same surface temperature. And now we will find the true habitable zone of the solar system when the sun becomes a red giant. And if R has to equal 1, which is the radiation received by a planet from the sun, then its distance has to be the square root of 3,000 times greater than Earth's distance from the sun, because 3,000 divided by the square root of 3,000 squared equals 1, and the square root of 3,000 is about 55, and so we will begin to scale up the habitable zone. Now we are moving past the orbit of Mars, past the asteroid belt, to the orbit of Jupiter. But Jupiter will, as we will find out, will still be way too hot to support life because it will be way inside the hot zone of a red giant sun. And now we scrape past the orbits of the gas giants Saturn, Uranus, and Neptune, but we're still not there yet. And now we have to take a look at Kuiper Belt objects such as Pluto, Quaoar, Haumea, Makemake, and Eris. Some of them will be habitable, particularly those that are located in the middle of the Kuiper Belt, about 55 astronomical units away. But those inner Kuiper Belt objects like Pluto will be too hot to support life because they receive too much radiation. And now we got a true scale. Any object that is located between 50 and 70 astronomical units will probably have liquid water on its surface, whether the proportion is just in its equator or the polar regions, or about the entire planet like the Earth. However, we have not factored in the sun's decreasing mass. When the sun's mass decreases, it means that its gravitational hold on the planet is loosened, which will cause the planet's orbits to expand. While the sun reaches its first peak in its red giant phase, by the way, the sun will have two red giant phases, each with a peak's luminosity of around 3,000 2020 solar luminosities. By the time it reaches its first peak, it will have probably lost around 25% its current mass. And the mass of the sun then multiplied by the distance from the planet to the sun will be equal to the result of multiplying the sun's current mass by the current distance between the planet and the star. And therefore, we need to multiply the orbital distance of all the planets from the sun by a factor of 1.33. And by the time the sun reaches its second red giant peak, it will have lost 45% of its current mass. And 100% minus 45 is 55%, and 55 multiplied by 1.85 will be around 100%. So by the time the sun reaches its second red giant peak, we have to multiply the planet's distances from the sun today by a factor of 1.85. In the first time the objects in the inner Kuiper belt like Pluto, Quaoar, Haumea, and Makemake will be in the habitable zone, and by the second red giant peak the sun reaches, Neptune will be at the habitable zone. And therefore Saturn will be way inside the hot zone of the red giant sun and unable to support life as we know it. And that's it for the video. If you guys have any more questions about the mathematical principles, whether I explained it vaguely or you guys have not really understand it, that will leave a comment and I'll probably respond to your questions with some mathematical concepts that we have established. And also, if you're going to leave a hate comment saying that I was stupid and Titan will actually be in a habitable zone when the sun reaches its red giant peak, I'll probably ignore you because I'll see you as trolling. By the way, it's true that Titan will be and Saturn will be in a habitable zone for some time because before the sun reaches its peak in its red giant for its two red giant phases, because the sun's luminosity will be smaller than its red giant peak, but much greater than its luminosity right now. And therefore, Saturn and therefore Titan will be in a habitable zone during these times. And if you like the video, be sure to leave a like and comment and subscribe. By the way, I'm not forcing you to. If you don't want to, then it's totally fine.